Welcome to LabMinutes.com. In this video, we will look at private VLAN configuration on Cisco Nexus 1000V. In case you're not familiar with private VLAN, what private VLANs allow you to achieve is network isolation by placing groups of hosts in different VLANs but still being on the same IP subnet. There's a concept of primary VLAN and secondary VLAN, which makes up of isolated and community VLANs. Hosts within the same isolated VLAN cannot talk to one another, while hosts in the same community VLAN can, but not across the community or to other isolated VLAN. All VLAN can talk to the primary VLAN, which is usually an exit point of the subnet or a common service that is needed by all hosts, things like DNS server. So in the first half of the video, we're going to have two Windows 2008 machines sitting in an isolated VLAN, VLAN 132. And then we're going to have two Windows 7 machines sitting in a community VLAN, VLAN 232. And then we're going to have another community VLAN, VLAN 332, where we put a Ubuntu machine by itself. And now three of these VLANs will be associated to the primary VLAN, VLAN 32. Okay, now the second half of the video, we will create a new private VLAN, and then we're going to move two of the Windows 7 machine into an isolated VLAN, VLAN 164, that's associated with the primary VLAN of VLAN 64. And then we're going to see what it looks like to have concurrent sets of private VLAN on the same Nexus 1000V. So with that said, let's begin our configuration. We're first going to configure the top half of our diagram here. On our Nexus 1KV, we do show feature. And here you can see private VLAN feature is disabled by default. So to enable the feature, you go feature private VLAN. Okay, the next thing we need to do is to create the three secondary VLAN that we have here, 132, 232, and 332. So start off with 132. And we have to specify as a private VLAN, type isolated. And we do VLAN 232. And we said 232 is going to be community. And 332 is also going to be community. Then we have to go back under VLAN 32 and make, before it was just a regular VLAN, but now we have to make it a private VLAN primary. And also we need to associate the primary VLAN to all the secondary VLAN with the command private VLAN association with a question mark. You see it right here, VLAN ID of the private VLAN you want to configure. And if this is the first time, then you just have to list out all the secondary VLAN. Otherwise, you can also have an option to add and remove. Okay, next we are going to create a port profile that we will use to assign to the VM. So start off with port profile type VETH, which is the default type. And I'm just going to call it VM VLAN 132. And here's just a standard VMware port group. Switch port mode instead of mode access, you do mode private VLAN, and since this is a host port, which is the host facing port, you said host. And then you have to do switch port, private VLAN, host association, and we have to associate to the primary VLAN at the port level. And we'll tell that the secondary VLAN for this particular port profile is 132. Here you go, no shut, and then state enable. Let me bring up the vCenter in the background so you can see. Okay, see the port get published, or the port profile get published up to the vCenter. And then let me do show run port profile VM VLAN 132. We're just going to copy this, then bring up a node path since we have two more port profile to configure. One is 232 right here, and then the other one is 332. Copy, paste, and if we go under host cluster and then networking, we should be able to see 132, 232, and 332 in there. Okay, so those are the port profiles for the main host. Next we have to modify, or actually create a new port profile for the uplinks to make it a Promiscuous port. That's on the primary VLAN, since it's going to be our path to the upstream gateway. So create port profile type Ethernet, since we're dealing with the physical link here, and we're going to call it uplink VEM private VLAN. Okay, and then you go VMware port group, switch port mode, instead of just trunk, it's going to be private VLAN trunk and specify as promiscuous port. Then you go switch port, private VLAN in trunk, allow VLAN, and we know we're going to be doing 32, 5960, which is our VMotion and iSCSI, 64, 111, which is for our Nexus 1000V, and switch port, private VLAN. The last command I have to do is mapping. Again, it's a trunk, so I have to keep telling it's a trunk. And then it says specify primary VLAN, and our primary VLAN is 32, and all of the secondary VLAN, which is 132, 232, and 332. Enter. Okay, and then now we have to create or configure a channel group, auto mode active, and then no shutdown. And we specify system VLAN. For us is 32, 60, 111, 113. So you don't have to worry about these VLANs, but if you watch our previous video, you would know what VLAN we're using for all the system stuff. And then state enable. You can see right here, it shows up on the vCenter. Okay, so let's just do a quick review with the show run port profile. Here's a command that we enter that's specifically related to the private VLAN. And if you compare that to the existing Uplinks port profile that we are using, you can see right here, this is where I get the switch port allow VLAN from. So same sets of VLAN, but instead of just a regular trunk, you specify as a private VLAN trunk. Okay, everything else looks pretty much the same. Now we have to assign these port profiles to whether it's uplink or a host. So go back to the vCenter, right click, go manage host. Let's give our uplink a try first. Just make sure we don't lose connectivity because we have all the foreign services running behind it, which is like vCenter and our jump box. So let's change our uplink and make sure we still have access to everything. Okay, looks like we are okay. Now let's continue with the rest with the manage host. Now this is for the ESXi2. We'll change the uplink. We'll leave these interfaces alone, and for the VMs, let's see. So we said the Ubuntu one will be in VLAN 332. So that will go to 332. The two Windows 2008 machine will be in VLAN 132. And the two Windows 7 machine is going to be in VLAN 232. And then we're just going to leave the vCenter on the same VLAN, so we don't lose connectivity to that. Okay, everything looks good, and then you click next, and then finish. Yeah, if you were to put the vCenter into VLAN 132, it will immediately lose connectivity to vCenter because we are accessing it through the Windows 2008 machine here. Okay, so before we move on, let's go back and check and make sure that all the hosts has been placed in the correct VLAN that we want. So configuration, networking, distributed vSwitch, and then we can look at 132. It's got the two Windows 2008 machine, and then 232. It's got the two Windows 7 machine, and then we got a 332 that has the Ubuntu machine. Okay, so it looks like everything has been put in the correct VLAN. So now if you go back to Nexus 1000V here and then do show VLAN, private VLAN, you can see now these VLAN has been assigned to those corresponding ports. Right here you can see VETH, which is the host port. Looks like everything is ready to go for our testing. Before we start testing, let me bring up the test machine. So this is the second Windows 2008 with the IP of 32.42. This is our first Windows 7 machine, test 1. It's got the IP of 32.128. Make sure we can still ping out to the outside. And we can. And this is the second Windows 7 machine, with the IP 32.129, and we can also ping out. And for the Ubuntu machine, it's got the IP of 32.130, and we can also ping internet. All right, so let's start our testing. Let's start off with our Windows 2008 DC, which is in the isolated VLAN 132. If this worked correctly, this should not be able to ping any other machines at all, but the default gateway. Bring up the command prompt, try to ping 192.168.32.42. You can see we cannot ping that. Neither that we can ping 128, 129, or 130. Okay, on the other hand, at the gateway, you can pretty much ping all the 5 IPs or 5 hosts that we have: 40, 42, 128, 29, and 130. The same thing, if we repeat the same test on the second Windows 2008 machine, we should get the same result since it's also in the same isolated VLAN. Cannot ping .40, which is the other host on the same isolated VLAN, and it cannot ping 128, 129, or 130. Now let's move on to the first Windows 7 machine that's on the Community VLAN 232. If it works correctly, it should be able to ping the other host on the same community, but not any other host that's on different community on the different isolated VLAN. Here, let's first ping the other host on the same community VLAN, which is 32.129. You can see it can ping that just fine. But the other host is on the other community VLAN, you cannot ping. Okay, and neither you can ping .40 or .42, which is the host that's on the isolated VLAN. All right, and again, same result if we do it on the other Windows 7 machine. Just want to repeat that so you can see real quick. Itself is 129, but the other host is 128. Cannot ping 130 or 40 or 42. Now the last host we're going to test with is the Ubuntu machine, and it should not be able to ping anything else since it's the only machine that's on that community VLAN. Okay, so the other hosts, let's start off with 40. Cannot ping 40. Cannot ping 42. Cannot ping 128. And cannot ping 129. But if you're trying to ping itself, you can see it can ping itself. Okay, so the second test we're going to do is to VMotion, just to make sure that everything continues to work. So we're going to VMotion this 2008-42 machine from ESXi1 to ESXi2. Okay, change host. Okay, so VMotion is completed. Let's get back onto since the host is moved. Let me bring up the screen right here. And we expect everything to stay pretty much the same. So can start off with pinging internet, which just works fine. Ping the other 2008 machine on the same isolated VLAN. You can see it cannot ping. And even across to the other community VLAN, 128, 129. And 130. So you can see even after VMotion, you still get the same result, which is what we expected. Okay, the last test that we're going to do is to ping the host that's on the primary VLAN. So in our case here, primary VLAN is 32. And there's one host that we currently have on that VLAN, which is our vCenter. Okay, so right here, it's on VLAN 32. So like I mentioned at the beginning of the video, basically all the isolated community VLAN should be able to reach a host or anything that's on the primary VLAN. So let's go ahead and do a quick check on that. We know that this host sure can communicate to vCenter because we are on it right now. Okay, and this one 1632.168 2.5. You can see we can also ping, and then let's go through our test machine here. They're 2.5, pingable from the first Windows 7 machine, here from the second Windows 7 machine, and the last one is the Ubuntu machine. So if you have like a server that provides a common service, things like DHCP, DNS, or like an update servers, then you can place them on the primary VLAN, just like how we have the vCenter in there right now. So now let's move on to the second part of our lab. So now we are going to configure the bottom half of this diagram, which is a scenario 2 here. We're going to create a VLAN 164 that's going to be isolated VLAN, and then we're going to move 2 of a Windows 7 machine into it. So back to our Nexus 1000V command line. Then we create VLAN 164, being a private VLAN of type isolated. And then on our existing VLAN 64, we make it type primary. And then we have to associate that to the secondary VLAN 164. Okay, next we create port profile, type V Ethernet. We'll call it VM VLAN 164. VMware port groups, switch port mode, private VLAN host, and then switch port private VLAN host association. Okay, primary VLAN 64, secondary 164. Okay, no shut, and go state enable. Okay, now let's take a quick look at show run port profile. Okay, so currently we have a mapping of our primary VLAN 32 and their secondaries. So we're going to do pretty much the same thing here with the VLAN 64. So private VLAN mapping trunk 64 164. And if you take another look at the config of the port profile, you can see there now there's a second entries under that port profile, which is the second set of the private VLAN. So to show VLAN private VLAN, you can see it also shows up right here. Since we haven't assigned to any host, you do not see V Ethernet shows up in this line here, which you will see in a second. So now we're going to move Windows 7 Test 1 to 164, and then Windows 7 Non-Corp also to that same VLAN 164. Okay, just wait here. Now it's completed. Just do up arrows and look at it again. You can see now we have VETH 17 and 16. Okay, so now let's repeat our testing. So let's go on to Win 7 Test 1. And since we just moved it to a different VLAN, VLAN 164, which is part of 64, we need it to retain new IPs. So let's do what it has right now. It still has the 1632 IP, so let's do a release renew. Renew. This time it grabs 64.34. And then we have to do the same thing on the second one, IP config, release, and then renew. And this one grabs 33. Okay, so let's do some testing. So again, come back and revisit the diagram here. So these two hosts before they were on Community VLAN, but now they're on as isolated VLAN. They should not be able to ping each other anymore. But at the same time, we should be able to ping anything that's associated to VLAN 32. Okay, so let's try that with test 1. Make sure you can still ping internet. That means you can talk to the gateway. If you're trying to ping the other Windows 7, which is 64.33, you can see you cannot ping. But if you ping anything in VLAN 32, see everything is now reachable because it's just basic routing, even the Ubuntu machine at 130. Okay, if you repeat the same test here, 1664.34. Yeah, it cannot ping that, but it can ping everything in VLAN 32. So you can see with the private VLAN, you can pretty much partition a VLAN into multiple isolated networks by using different VLAN number being a secondary VLANs, and actually without having to even come up with multiple subnets. You can see here all these VLANs share the same common IP subnet. And you can also have concurrent sets of private VLAN, just like how we demonstrated in this lab with VLAN 32 and 64. Okay, so that wraps up our video on Nexus 1000V and private VLAN. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.